Hello, everybody. My name is Dale Phillips, and I will be your guide this semester. And I have a generalized, generic way of starting my classes. So what I'm going to do is that I am letting you know I'm in the CAT building, room 231 upstairs, and it's the Jeremy Lab. And what we have is 30 machines that are all fitted out with Linux, Jeremy Michael Kelly Linux Lab. We'll get to that in a second. But I want to start off with a couple little doodles here. And I'm experimenting with all this technology. So I am playing around with an old video camera, a wireless mic, and this is my first semester to give it a shot at remote, where we meet at the same time and we have a Zoom meeting. I want to start off with a couple little silly pictures. So you'll see this. Those are actually my initials, but this could be a butterfly walking on a tightrope, or that could be a man with a bow tie too close to elevator doors. You can see that a very simple drawing can have very many different meanings. And that's the point of all this silliness, is that here's a big circle, and here's a circle. Now, what's that? Well, that's an overhead view of somebody riding a bicycle with a very big hat. As you can see, it's pretty ridiculous. So what I'm going to do is, with these funny little doodles, is I'm going to go to a screen share now, and we're going to walk through a few things that we'll be doing. Now, here's the screen, and computer science in general has a superpower, and it's called abstraction. This is the ability to see things decomposed, shall we say, take it apart, see it again. Some of you may be able to think in 3D, think in objects and images. That's helpful, but not mandatory. But here's one of those silly little pictures that we have here. Everybody's going to immediately look at that and say, oh, that's the power button. But what else do you see? It's a 1 and a 0. That is computer science. Everything, as of today, is ones and zeros. I mean, everything. So we also have some other things in this discipline that you take for granted that you see, and once you get into this field, you can solve problems other people can't even see. And here's an example. I have a clock. It broke. So what I had to do is that I had to move the minute hand where the hour hand was. So basically, I have just a long hour hand, but there's no minute hand. Can you still tell time? Well, yes. It's somewhere between 1 and 2. And then if you figure out the dots, I'll tell you they are between 10 and 15. And you can figure that out while you're listening, is it still takes a full hour to go between 1 and 2. So how many dots do we have? We have 1, 2, 3, 4, 5. And when we have 5 dots, 60 minutes, what's 5 divided by 60? There you go. That's right. So we now have the ability to look at a clock through a different lens, but it still works. It's functional. Okay. And here's a fun picture I like to show. This was done in 1954. And this is what they predicted the computer would look like in year 2004. And if you look at that closely, that's quite a computer, isn't it? Well, this was actually taken around 2004, I believe, at a trade show / conference / art gathering. And what you're looking at is a control from a submarine, an old television and a teletype machine and some old guy who looked like he was from 1954. So this is the reiteration of not all things are as they seem. Okay. So here's another thing that we have a problem with is none of you or even your parents would remember this. This is information that got obsolete. These are worm drives, write once, read many. And these things were all the rage. They basically, they wrote on glass. But look at the dates. Okay. What killed this entire industry is that they would not work with each other. So if you had one from Plasmon, it didn't work with LMS. Do you remember the beta VHS? Well, everybody seemed to learn that we need to have universal standards. So now we have DVDs made by multiple people and CDs made by multiple people, and they all work in everybody's drives. So this is where open source and the Linux kernel is also evolving. Okay, so it's kind of cool. Now, I don't know if this is going to work it's going to be playing in the classroom speakers, and it's going to be picked up by the microphone that I'm wearing. So let's see if this actually works. I'm not even sure if it will, but we'll see. Whoops, let me connect the sound card. Turn the volume up. No, it's not going to work. I'll post this and you can listen to it later. No big deal. And then this is something that is fun. This is a straight frequency at 14 kilohertz. If you're under 40, you can hear it. But if you're an old guy like me wearing hearing aids, you can't. So this is why the world is flat. This picture depicts the power of the fiber optic cable. All you have to do is change the switches on either side. And what happens is you can still increase bandwidth through that same piece of fiber. Fiber optic is glass. That's one cable that was undersea, and that's completely been changed by that single thing that this guy is holding. It looks like the little red dot right there. That's actually the laser light coming out of it. They are now getting more throughput by putting the colors of the rainbow and multiplexing this. So this is pretty cool. And in 1947, this was invented, the transistor. This is what made our world so crazy today. That was a single transistor. And this is where they talk about who invented it and how it happened and a little bit of the serendipity of what happened. But here is where your Apple 8 system on a chip. I want you to notice that how many transistors are in your iPhone now? 2 billion. 2 billion transistors. And we're just getting started. This stuff here, the FPGA, stands for Field Programmable Gate Array. And this is where it's all headed. You have this entire 1,200 racks with all this wattage being replaced with a single rack at 12,000 watts. Now, there's a lot of computer science going into this. And if you're interested in computer engineering, this is the stuff you'll need to learn. And I can point you in the right direction for that. Okay. And all this stuff here, let me say this, is I'm going to quote Einstein here. You see a wire telegraph is kind of a very, very long cat. You pull the tail into New York and its head meows in Los Angeles. You understand this? Radio is very much the same way. You send signals here and you receive them there. The only difference, there is no cat. Albert Einstein. Computers are built on these signals, but they move the electrical signals, the sine waves, into ones and zeros. Everything is ones and zeros. Think of an abacus, things that the calculator that came out of Asia, with little beads on it. You can count it. You can add and subtract, multiply, divide very quickly with integers. However, trying to represent 3.12 or 1416, in an abacus is very difficult because you don't have beads between the 3 bead and the 4 bead. That is discrete structures. That is the shall we say, the foundations of all computing today. The concept of how do you manipulate ones and zeros to do things that we play games, manipulate colors, all this stuff. It's all ones and zeros. So this is just from Discrete Structures. Go read about it. Discrete Mathematics. George Boole created a algebra that allowed you to create equations using all these ones and zeros. And it's if you get in more into computer engineering, where you design and build your own chip, discrete structures and Boolean algebra will become one of your tools. Okay. And on that note, here we have, thanks for listening. And boom, it's never done that before. And what I want to show you now is a little bit about me. Here's my website. I've been teaching since 2005, and this is my vanity plate. phillipsd.com is a domain that I own that runs on a Linode instance, $5 a month. I have an email that works for that. If you were interested in all that, I teach the Linux classes on how to do all this fun stuff. And here's the Jeremy Lab. And what I'd like to have you do is watch this video so you can see how awesome the lab is that we don't get to play in this semester, which is kind of sad. But life is what it is. And these are some other things that help you navigate the school. So what have I been doing? Well, I've been working in tech. I think, let's see, is it this one? Yeah, here we go. I was in college for 35 years and 8 months. I have 2 master's degrees. And here's the companies I started with. I worked for this company for 5 years, this company for 8, and Foster Farms for 7 years. And they were all high-tech positions. I did networking, database admin, programming, scripting, web dev before it was called web dev. So I did DevOps before it was called DevOps. Been around a long time. It's still my hobby. I still have fun with it. You should see my computer at home. It's got 256 gig of RAM. It's got a AMD Threadripper 64 core, screaming fast, way fun. I use it for virtual machines. I'm not a gamer, never have been. There's more interesting things to do to me in the world of computer science, neuroscience being one of them. I've got this little device that captures brain waves. It's kind of fun to watch your brain waves change as you're thinking about things. And the Jeremy Lab that I'm standing in now has been around for 11 years. And I've been in high tech for 37 years. And I've been twisting the knobs on Linux for about 31 years. So I am a Linux bigot. I run everything on Linux. I virtually never use Windows. I've even converted my home all to Linux. And now with the Outlook working quite well inside of Chrome or Firefox, that's the only reason I ever needed Windows, was for the system email that we use here on campus. So that was a short little riff of what I'm about, where I'm coming from, and some fun things to look at. And I'll post all this stuff up. I'm learning how to use Sway, which is a tool that takes an existing website or a I guess you would call it a document, and that turns it into a really slick website. And then it gets posted on Microsoft servers, and then they run analytics on it to find out how much usage that is. So everything you do for free, you're being watched, and your click habits are being marketed to. So that's the way it is right now. Okay. All right. And that is the last of it. And we will be using Canvas this semester. And so when we get into Canvas, the shells will be ready by Monday. So here's where our classes will be. And this semester, I am teaching 271. We'll be using ZY books. This is Python. We're going to be learning Python at a much deeper level. And then I'll be teaching networking. We'll be using test out. And when I teach the Linux class, we'll be using test out. And then I'll be teaching the final projects class. And this is also a remote class where we'll meet on Tuesday evenings, and I'll bring in guest speakers, and this is a portfolio building class. So that's kind of in a nutshell, where we're going. Stay tuned. We'll be doing more as time moves along. And I will also be using Slack this semester. And the reason I use Slack is because if you get into this industry and you do programming for a living, you will be using Slack or Discord or some tool like that, where you have this collaboration, screen sharing, team exercises and things to do. It's a fantastic communications vehicle that covers many different, it's like being next to somebody even though they're not, you can be on the other side of the planet and everything works and communication's good. It's well worth learning how to use Slack. Okay. So on that note, I am going to stop my share and then zoom out a little bit here and see, zoom back. There we go. This is goodbye from our classroom, and I shall see you all online.